So writing a function is reversed, and we're going to check the string. And if the length is not the same, we just return. We don't even need to check anything. So I'm going to start writing the function. So we have public. It would be faster to check the length first because it doesn't have to run through exactly. So the first thing we can do is check for the length. We'll do public static. What's the return type? Boolean. Yep, Boolean. And the name of function is reverse. And we'll do string a string. The first thing we need to do is check for the or before we even get to that, what would be the base case? Like where would the recursion stop? A equals to B, comparison is false. So the idea here is, so now let's say we have, let's do level, and the second string is level. So now what we need to do is pair this one with this one, right? And then compare this one with this one with this, and then at the end of the string. So when we reach the end of the string, we need to, what index is this? 0, right? So it starts at 0, and then 1 and all the way up. And this one starts at 0 and goes all the way up. So what's the index of the last one? Length minus 1. So we do length, whatever the length is, minus 1. And string, remember, strings are objects, so they have built-in functions. So we can use one of those functions, and it's called length. So length, we can find the length of the string and get the index of the last one. So we can pass in 0, compare the 0 index with the last one right there by doing something like this. And we can cut this off as soon as we compare it, and the string that's left is that. Then we can compare this string with this one. Then we only have VEL and LE, and we can keep doing this one letter at a time in recursion. And when we get to the last one, we compare this one, and when we run out of strings, what is the length? So when we compare all of them, what length is 0, right? So if the length is 0, then that means we've gone through the whole string and we don't have anything left. And when we get to the end and we haven't found anything that does not compare, that means the whole thing is, we'll just do that could be the base. Do if a dot length equals to 0 and b dot length equals to 0. In this case, return, then we do or instead of and. So we gotta make sure both of these two are at the end, right? So return true, else what should we do in the else, or should we need an else if, or what do we could have like a else if here, and or not, depends on how you want to structure this. So this would be the base case, right? So, and going back to this right here, should we even check for each of the character if the length is not the same? The expected return value if two empty strings are used in argument. So if the two empty strings are passed in, that means the length is 0, and that will just return because they're the same. So if else if a dot length is not equals to b dot, then what should happen in that case? If the length of a does not equal to length of b, return false. So we can return false, and then else would be, so we got the base case, we got the special case. This wouldn't be a special case. This would be just to check if we even need to do the recursion or not, and everything else would just go in the else case. Because if this is not true, then we need to run recursion. What happens in the recursion? So remember, we need to check the first letter with the last one. How do we get the first letter and compare it to the last one? You slice it, substring, you can do any of that. So how would you do any of that? Each letter in a string, we had level right here. So L would be known, the whole thing is a string. So each character is like known as a char. Char is like a character, and the short form of that is just char. You can just use char. And we can do letter 1 equals 2, and then there's a built-in class. There's multiple ways of doing this. So if you have another code that you want to go with, that's fine, or you can share with us. But the easiest way I can put is, you can char at, it's a dot char at, sorry, not char at the index, and that index would be 0. So we have letter 1, then we can do the same thing with letter 2. How would you do letter 2? And b dot length, and the length would actually need the function just like this. Yep. And whatever the length of b is, minus 1, and that would give you the last index. So we're going to get the last index using this, and then we need the last index of not a but of b. So we're going to compare the first letter of a string with the last letter of b. So we got letter 1 and letter 2. So now we have if letter 1 equals letter 2, else. So what should happen if the letter are the same? What should be the next step? So we compare the first one with the last, and then what should we do? If they are the same, we need to move forward. How can we move? So you need to do iterative case or recursive case. how would we write that? So we know in recursion we need to call that function, and then what goes inside the function? Remove char at index one of a and index. So remember passing in a new string, right? So is there a function that we can, instead of removing char, how would we remove the first substring? So there's a built-in function called substring. How does that substring function work? Starts at index and then ends at index plus one. So the substring method, so if you don't know what that does, we can always look it up. So what that does is starts at you give it an index name and then starts at that index and then it goes all the way to the end of the strings. Look that up. Substring Java. Let me see if I can find documentation on it. Or so Java substring method. Jennifer, would you have would work too? Or if you don't want to pass in two indexes, we can use something like this right here. So they have a string Java point, and that if you pass in just like one index, it takes that all the way up all the way to the end. So it starts at index 2 and prints that point. So for the first one, you can just start at index whatever you want to cut off from the first and just pass that in. And the second one we can use. All right, so now we have a substring 1. So it starts at 1, whatever the index is, and it goes all the way at the end. So we skip the first letter. And the next substring is b.length minus 1. This one, what would this be? Substring, remember, if you do something like this, then this would be an empty solution. I'm going to copy hers or just modify this one. So b dot substring starts at 0 and goes all the way at the end to length minus. And when we do length minus 1, that letter is not included. The substring, and is that it inside the if statement right here, or do we need to add anything? So what happens in the else? They're not equals. That's it inside the if. All right. And what happens in the else? Return false. So we got two letters one from A, one from B. First letter from A, last letter from B. We compare it in the if statement. If they're the same, we continue looking for other letters, right? If they're not the same, we just return. So we have what string were we working with? So let's do A, B, C, D, A, B, C, and then we have C, B. So we're going to compare this one, A with A. So we're going to come in, check if the length is 0, the length is not 0. Then we check in here, the length of these two does not equal. They are equal, so we go in the else part, and else we take A right here. Then we take A from B string right there. And one thing we're missing inside the if statement is what? Take a substring of A with just these two, right? And we take the substring of B with just C and B. That's what's going on right here. But in order for this to work, we need a return state. So whatever this returns, we need to return it to the main level. We need to return the whole recursive. So let's go over what's going to happen. So now the second level, the strings we have is BC and CB, because that's what we did. We check the base case. That's not the case. We're not at the end. Check the length is not the same. They are the same. So we go into else part. In the else, we extract B. We extract this B. Compare it. They are the same. We go into recursive case and we extract and we pass it along the next recursive case. So the next case we have is C. And so now we come in here. We check the length of C, it's not 0. The length is the same. We don't go in the else if. We go in the recursive case. We extract char at C, and then we take the last letter, which is the only letter we have. We compare these two. They are the same. We go into the recursive case, and then here what we do is take an empty string. So we take the C out, we take an empty string, and here we take the C out again. We take the empty string, and we pass that in. So this is the next level. When the empty string comes in here, that's where the length is equals to 0. And the same thing, the length is equals to 0 for A and B string. This is where we return true. We return true to the upper level. True gets returned. And this, all it's doing is carrying that true up the level every single time. So this returns true, this returns true, this returns true, this returns true. That means we were not able to find anything that were not every single character was equal. So we just carried that true up. So let's run it and test it if that's even working or not. So we have system.out.println. I'm going to call it is reverse and then pass in B. So that returns true. We'll change B to D in the second one. and run it again, and that returns false. All right, so let's trace this string and see how it's returning false. So now the string is A, B, C, D, and then we have, what is it? D, C, D, A. Mine uses returning true. Let's go over it and see why would it return true, or maybe you're missing something in here. So let's say this is the string. The first time we come in here, we check the base case. That's not true. The length is 4 for both of them. They're not 0. The length is equal, so we don't go in the base case. Then we go in the else case. We extract here A with A at line 21, and that is true. So we go in the recursive case, and the new string is B, C, and then we have D, C, D. So now we do recursion. We pass that string. The length is the same. Length is the same. It's not 0. We go in the recursive case again. Then we compare B with D. Now it's not the same. What we do is we return false. So we don't go inside the if statement. We go in the else part. We return false. We return false to the upper level. And we have a return statement here that returns false, and that just returns false all the way. So we don't even check the rest of it. As soon as we find one that's not true, we just throw throw false. So everybody's working. So the in-class assignment for today is, I believe it's a little hard. First, you have to write a method called remove odds, and second one, you have to write a method index of. So you have two strings, you need to compare them. So it's very similar to what we just, the remove odds one. Let's go to get started on that together, and then you can finish it. So in here, one integer is passed, right? So we can call that n, and then all the odd numbers are removed. So 6 is an even, 1 is an odd, so 1 is removed, this one is removed. We keep 2, we keep 4 because those are even, and we remove the 3, which is odd. So the end result just even number. We have one parameter coming in, which is n, and we remove all the odd values. So how would we get started? First, we're gonna write the function. I can already tell we're going to be boxing. So we do, remember, integers don't have indexes, right? So we just worked on something similar. We can compare something with the index of a string, but integers don't have, so we need to compare it one at a time. So we have public, static, and what would be the return type? Because the return value is an integer right here. So we need to just remove those and keep the even number int, and then the name of the function is remove, and parameter is, what would be the base case? So why is integer I equals to new integer a? Get it? A is my parameter. Trying to create integer object where the parameter, don't know why it's done that. I can look into that and let you know, but I'm not sure why. But we're not allowed to create new integer objects. So we need to work with what we have, so it'll be just integer. If you don't know what the base case is, what would be the special case? So if you go back and read the question, everybody go ahead and pull up the question in here. So what's the special case? One of the special cases, 0 will return 0. So if n equals to 0, and then we return, or to make it simple so everybody understands, else do something. What, so we have a number, let's say we have number 2, 5, 6, like this. Now we're checking for 6. How do we extract 6? To see if it's even or odd. So if you do mod 10, that will give us the last number, and if you do divide by 10, that will get rid of the last. So if you do int last number equals to n mod 10. So we can have an if statement. If would be this. So how would you type all that in code? So the first thing we need to check if that last number is even or odd. So how do we check if that number is even? What's the code to do that? Mod 2, so if you do last number mod 2, if that equals to 0, then we have even number. If not, this is an odd number and we need to do something else. So both of those two would be return statement, right? We'll need to return something. So one hint you can take from here would be, when you have a return value right here of a function, make sure each if and else statement has a return value. Doesn't matter if it's a base case, doesn't matter if it's a recursive case, you will be returning something. Good, so keep that in mind. In recursion, If your function returns something, you'll have a return statement in each of the case. Even Java will. You need a case right here, and you need a case for odd number. So I'll leave you at this and figure out what those cases are, and I'll divide you guys up into groups, and you can finish. Would you want to return null if it's odd? No. So in this case, remember if it's odd, you still need to move on to the next digit, right? Yeah, you don't return 0. So you compare like 6 right here. Then 6 is even. You still need to compare this one, but you need to keep track of 6. Then if let's say you had a number 255, and then you compare 5, you still need to check the second 5 or the first 5, but you need to get rid of 5. So in this case, you need to keep the 6. In this case, you need to get rid of 5. So that's the difference between the number is even or number is odd. You still need to go through it, but you gotta figure out if you want to keep one or the other, and how can you keep one.